Let's start with the function f of x equals x squared minus 3x. So I'm going to begin here just by evaluating this function. Let's say we want to evaluate this function at a value of x equal 2. So I replace x with 2 throughout, and using parentheses as needed here. So we have 2 squared, clean that up a bit, minus 3 times 2. So it's a good idea in some cases to put parentheses around whatever you're replacing the x with as you work through it. So f of 2 is equal to 2 squared minus 3 times 2. So now we just do the arithmetic to evaluate this. So 2 squared is 4, and minus 3 times 2 is 6. 4 minus 6 is negative 2. So when we evaluate f of 2, we end up with negative 2 for this particular function. So there's no reason that your input value has to be a number. What if we wanted to evaluate f of the letter A? We would do the same thing. That would be a squared minus 3 times a. The difference is we can't really simplify this. We can remove the parentheses, a squared minus 3a. Okay, let's get something a little more complicated for the input value. Let's evaluate f of a plus 2. So again, keeping the parentheses, a plus 2, that whole binomial there goes in place of the x in the original function. So a plus 2, quantity squared, minus 3 times a plus 2. And when you are inputting a value that is more than one term, in this case a binomial, 2 terms, it is even more important to use parentheses. So a plus 2, quantity squared, means a plus 2 times a plus 2. The negative 3 can be distributed through the parentheses in this step. So negative 3 times a and negative 3 times 2 turns into negative 3a minus 6. And a plus 2 times a plus 2, we can either use what we call FOIL to multiply these two binomials together. FOIL stands for first, outside, inside, last, or some people prefer saying first, outer, inner, last. But whichever way you say it, it means we multiply the first terms together, then we multiply the outside terms together, then the inside terms together, and last, the last terms together. So that will give us a times a, which is a squared, for those first terms multiplied together. And the outside terms, a times 2, would typically be written in the order 2a. And then the inside terms, 2 times a, that's another 2a. And last terms, 2 times 2 makes 4. And then we still have minus 3a minus 6. So now combining our like terms, a squared, that's the only squared term that we have, because remember, like terms, the variable part, which is the variable and exponent together, that's called the variable part, must be the same in order for two terms to be alike. And in order to add or subtract terms, the terms must be like terms. So now we have three terms which contain an a to a first power. So if we add those terms together, we just add the coefficients. So 2 plus 2 makes 4, minus 3 makes 1. So plus 1a, which we would normally just write an a there, but you can write the 1 if you wish, if it's helpful to you. And then the constant terms, which are the terms that do not contain the letter a, would be a positive 4 and a negative 6. So when we combine positive 4 and negative 6, that is negative 2. So this is composition of functions, basically, is what you're doing here. The input value is a function of sorts. It's a function of a. So we put that expression, a plus 2, in place of the x in our original function f of x. So let's do another one. Let's start this time with a function f of x equals 3x minus 7, and g of x equals x squared. So let's figure out or evaluate f of g of x. Now this symbol here, which looks a little like the word fog, means the same thing as f of g of x, written that way. So as in many things in math, we start inside the parentheses. So inside the parentheses here, I'm going to replace this g of x with what g of x is equal to. So in other words, x squared is going to go right there in place of the g of x. So doing that gives us our next step, which says f of x squared. So f of x squared tells me to put x squared in place of the x in the function f. So that will give us 3 x squared minus 7. And 3 times x squared is normally written without the parentheses, so I'll just clean that up at the last and have my final result here for f of g of x is 3x squared minus 7. So now let's continue on and figure out. I'm going to split my screen here a little bit. So let's figure out this time, going the other direction, we'll do g of f of x. G of f of x can also be written as g of f of x this way. And now we need to, again, starting inside the parentheses, we are going to replace we're going to replace this f of x with what f of x is equal to. So that goes right down there. So that will give us g of 3x minus 7. And that means we put 3x minus 7 in place of the x in our function g. So that means we get 3x minus 7 quantity squared. Now we just need to multiply that out to simplify. So 3x minus 7 times 3x minus 7 and using the same process we did a couple of minutes ago on that other problem, we're going to take 3x times 3x, 3x times negative 7, negative 7 times 3x, negative 7 times negative 7. So that will give us 9x squared, 3x times 3x. 3x times negative 7 is negative 21x. Negative 7 times 3x is negative 21x once again. Negative 7 times negative 7 is positive 49. Now the only thing left to do is combine the like terms. And the like terms that we have here are negative 21x twice. So that will give us a final result for this composition of functions, 9x squared minus 42x plus 49. I really hope this helps. Please ask more questions if you need additional videos besides the ones that are included in Canvas already. I'm happy to make videos, but I need to know what you need. So please continue to ask questions. Hope this helps.